We are covering section 6 today. So we've learned how to work with rational expressions. Today we're going to solve rational equations. So to do this, right, here are the steps that we're going to take. First, you have to factor, if possible, right, in the numerator and denominator. After you do that, you have to state the restrictions. These are the points where the denominator equals 0. Okay, those are the restrictions. Okay, then you identify what the LCD is between all of the denominators. You multiply both sides of the equation by the LCD. You solve for x, and then you have to check for extraneous solutions, because if you have a rational equation, is the domain all real numbers of a rational equation? No, right? Because there are terms that make the denominator 0. So you have to make sure that you don't have any extraneous solutions. Okay, let's go ahead and do the first one. So here there is nothing that needs to be factored. What you have to do is first identify the restriction. What we do is we take any denominator that has a variable and we say, okay, 3 minus x can never equal 0. So x can never equal 3. That's the restriction. All right? Next, identify what the LCD is. So the denominators here are 24, 4, and 3 minus x. Between the integers, the constants, 24 and 4, the denominator, the LCD will be 24. And then times 3 minus x. Okay?
Is it the restriction?
No, because there are no more variables. It's only where the variables can equal 0. Right, so now we're going to multiply every single term here by the LCD. So this by the LCD, this, and no, you have to multiply all of it by the entire LCD. When you do this, when you are done with the multiplication process, you are not going to have any more denominators left. The denominators should all be just 1. So here, the 24s will cancel. So you have 5, 3 minus x, plus the 3 minus x's will cancel. So 48 is equal to 6, 3 minus x. Okay? All right, so what do we have now? Let's distribute. We get 15 minus 5x plus 48 is equal to 18 minus 6x, right? So x eventually will be negative 45. So now, how do we check for extraneous solution? Okay, when this goes into the denominators, any of the denominators, it doesn't make any of the denominators 0, so we should be okay. All right? Okay. Next one. So here, you notice this can be factored. We're going to factor it as x minus 5, x minus 4. So the restriction, right? X can't equal what number? 5 and 4. You have to set each denominator equal to 0. So x minus 5 can't be 0. X minus 4 can't be 0. The LCD is going to equal what? X minus 5 and x minus 4. Okay? So you're going to multiply each term with the LCD. So x minus 5, x minus 4, x minus 5, x minus 4, and this one. So what we have left is 8 times x minus 4 minus 9 x minus 5 equal to 5. Right? Again, if you're left with some denominators, you did something wrong. So distributing 8x minus 32 minus 9x plus 45 is 5. Negative x equals negative 8, so x is going to be 8 here. Okay. Any questions? All right, go ahead and do the next one. So for the next one, you have to factor the denominator, right? Here. Don't factor that numerator. You don't have to. You should, because you're going to end up multiplying it back later. So what are the restrictions? Negative 5 and negative 3. And what is the LCD? Right. So multiply. Okay, here's another way you can do this, but you know, just make sure you don't forget any terms. This is another way of writing it, but make sure you multiply each one by that red LCD. So we're going to have 2x, x plus 3, minus this polynomial, okay, equals 3 times x plus 5. All right? All right, so let's go ahead and solve for x. I'm going to race you to it. On your mark, get set, go. Okay, so you should have gotten to this point, right? X squared plus 4x minus 5 equals 0. When you simplify everything. Yeah? Now we're going to factor. Yeah. Did you get this or no? Okay, so where did we go wrong?
Distribute the negative.
So there is an,
Oh, I see.
there are, you know, several x squares.
I see that.
Yeah. So now this tells you x equals negative 5 and x equals 1. But, because then you bring the 3x over. So what's wrong with this now? X can't be negative 5, right? Because it's a restriction. So you throw that away because it's the restriction. So the only answer is x equals positive 1. You cannot put the other answer. What I want to see in your work is I need to see that you are able to find x equals negative 5 and x equals 1. I need to see that between the two of them you threw one away and you only selected 1. And then that x equals 1 is the only thing in the answer space. If you put both of them, you will for sure lose 1 or 2 points. Okay. All right, so the next one, we're going to factor this one. It's going to be z minus 1, z plus 1. So the restriction is z can't be plus or minus 1. And so the LCD is z minus 1, z plus 1. You multiply. So we're going to get 2 times z minus 1 minus z plus 1 equals negative 2. I can already see students here forgetting to distribute that negative, right? So here we're going to get 2z minus 2. You know what? I'm going to cross my z's so it's obvious. Okay? So you have 1z equals 1.
That's a restriction.
That's a restriction, so it's no solution. All right? Okay. All right. And now, because what's the point of doing math without some word problems? That's what we're going to do next. Isn't that lovely? Okay, you guys ready? Yeah, that's why I like to cross the Z's here. Okay? All right. Okay. All right. So let's move on. We're going to talk about concentration in the next one. This concept we're going to talk about is called weighted averages. So let's take a look at this problem. Jimmy adds 65% fruit juice solution to, so this is what he's adding. So there are two solutions here, to 15 milliliters of a drink that is 10% fruit juice. How much of the 65% solution must be added to create fruit punch that's 35% fruit juice? So let's talk about what's going on here. You've got this solution. It's got 15 milliliters. Oh, you know what? Let me do that in red. It's got 15 milliliters. And it's 10% fruit juice, right? That means if you had 100 milliliters, how many milliliters would be juice? 10%, right? Okay, but it's too dilute for him. So what he wants to do is he wants to add some amount of a 65% juice solution. So now this one is way too concentrated, but when you add it to this, right, the concentration of this is going to increase a little bit, right? It's going to be more juicy, right? So what we want to know is the exact amount to add in order for this to be 35% fruit juice, right? So let's remind ourselves, what is concentration? Concentration in this case is basically it's basically the amount of juice over the total amount of solution. Okay? So if I have a total, like 1 gallon, how much of that is actual juice? Does that make sense? So here's what we have here. Let's take a look at amount of juice. In the original, I have 15 milliliters, but 10% of it is juice. So how much actual juice is there? It's 15 times 0.10. Does that make sense? That's how much juice we actually have. All right. How about in the added part? How much did we add? Do we know the amount that we're adding? We don't know the amount that we're adding, but we know the percentage, it's 0.65. So the new amount is 15 times 0.10 plus 0.65x. Okay, that's the actual juice. Now let's talk about the total solution. In the original, there is 15 milliliters of total solution. How much did we add? We don't know, X amount. Total is 15 plus X. Okay? So what we're going to do now is we're going to focus on this. All right? So the amount of juice over the total solution, how much do we want that to be? 35%, which is 0.35. Okay? And now do you see how it became a rational equation? Yes. Okay, so let's just simplify some numbers here. What do we have here? What's 15 times 0.10 these days? 1.5. Okay, so now there is a couple of ways that you can do this. One way is you can multiply through by 100 and get rid of the decimals. Yeah? So what you can do is, because the most amount of decimals you have is 2, you can multiply this by 100 and you can multiply this by 100. So what you get is 150 plus 65x is equal to 35 over this. Okay, so how are we going to solve this? What's the LCD here? Yeah. Because if you multiply a fraction, what's the LCD here? 15 plus x. So multiply this by 15 plus x. You can also cross multiply this one. It's the same. So we get 150 plus 65x is equal to 35 times 15 plus x. 35. All right, so how much is that? Can somebody tell me what 35 times 15 is? And then skipping, x is going to be 12.5. So this is how much of the 65% solution we're going to add. So it's going to be 12.5 milliliters. I'm actually going to make another chart for this one. So the speed of the wind is 20 miles an hour. It takes the plane 7 hours to fly 2,368 miles round trip. Determine the plane's, this should have an apostrophe, determine the plane's speed in still air. Okay, so this is a speed and time problem, right? And remember we revisited this in the last unit. So the way I know of the speed formula is speed is distance over time. If speed is rate, then rate is distance over time. Okay? So now, take a look at what we're going to do. We are given 7 hours, right? It takes the plane 7 hours to fly with the wind. Okay, so here's how we're going to do this. We're going to create a little table for us again. Yeah. So time it takes with the wind. Time it takes if you're going against the wind. And then the total time. Okay, so it takes the plane 7 hours to go back and forth. The wind is only going in one direction. If you're traveling with the wind, you're going to go a little bit faster. If you're traveling against the wind, you're going to go a little bit slower. So it's not going to be 3.5 hours, right? But the total time is going to be 7 hours. It could be like 3 hours and 4 hours, okay? So because we're given the total time, we have to write both of these in terms of time. So how can I solve this for time? How can I solve that for time? R times T will be D. So T is D over R. Okay? So now, how much is the distance? How much is the distance halfway against the wind and with the wind? How much is each of the distances? So divided by 2. It's 1,184 miles each way. So we need distance over the speed, okay? The distance, if you're going with the wind, right? Is your speed higher or lower than usual?
Higher.
Higher. So it's going to be R plus 20. Okay? Because the wind is going to give you an additional 20 miles an hour speed. If you're going against, you're going to be traveling 1,184, and now your speed is going to be less by 20. And all this is going to be 7. Okay? So, no, because it's R, huh?
Well, if we're finding the still air,
Right, but it was never in still air, right? Because what we have, the 7 hours, it was in the wind. So, you know, we went a little faster because of the wind, we went a little slower because of the wind. But R, once we solve for R, that'll be the speed without the wind.
oh, okay.
Yeah, Julian, you with us?
Because these are all going to be the same equation, shouldn't the time be,
Let's go.
shouldn't the time be the same unit because it's plus 20 full time units?
Huh?
Full time unit 7 and then get it in 20. Oh, no, never mind.
Okay, 20 is the additional and less speed. Okay, so now
I got mixed up.
the time it took here plus the time it took here adds up to 7 hours altogether, right? And then after this, it's the same thing as what we've been doing. So what is the LCD here? R plus 20, R minus 20. So here we're going to multiply R plus 20, R minus 20. Okay, so what are we going to get? 1184 times R minus 20. 1184, R plus 20 is equal to 7, R plus 20, R minus 20. Okay, so it's not that bad.
Then you can cancel out the 20.
Right. Well, okay, so look at, what is this? What is this?
Well, that's just R squared.
R squared minus 400. Okay, so let's start distributing this stuff. So we get 1184R minus 23,680 plus 1184R plus 23,680. They're going to cancel out.
Can you cancel out the 30?
Yeah, just don't get lost in the theatrics. You know what I mean?
Yeah, I was just wondering.
Yeah. So these are going to cancel out. And then this, we already know the number. It's now twice of that number, which was, how much was the total distance? 2368. Okay. All right, bringing everything to the same side.
2368R equals
Yeah.
how would we solve?
So here's how we're going to solve it. 2368R minus 2,800 equals to 0. Plug it in your calculator. Graph it. Graph and find the 0. R would be 339.5 miles an hour. Now, when you graph this, are you going to use the normal negative 10 to 10 window? No, you have to go up into the hundreds and the thousands and the whatevers, right? Now, when you graph this, what's on your x-axis? What's on your x-axis when you graph? It's this R, right? That's here. What does R represent? R represents the speed of the airplane, right? If R represents the speed of the airplane, well, you know the airplane's not going at 20 miles an hour or 120 miles an hour. You know the airplane is going at multiples of 100 miles an hour. So that's how you know to get your x-axis farther out, okay? All right, let's quickly do the other stuff. Okay, there's more. One more page. Okay, so solving rational inequalities, same thing. state the restrictions, and then we're going to solve. But now we have to get a range since it's an inequality, right? We have to get a range of values. So let's do that. Okay. 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 What are the restrictions here? So basically x can't be 0, right? What's the LCD? 9x. Okay, so what we're going to get here is 12 plus 63 is less than 5x. Oh, you know what? Let's make it easier. Let's solve it as if it's an equation. Okay? Let's solve it as if it's an equation for now. Huh? Because it's between a 3 and a 9, so that'll be a 9. Okay, so let's solve this. So 75 is equal to 5x, and x is equal to 15. Okay? We're good? Now, we're going to make ourselves a number line. On this number line, we're not only going to put the 15, but we're also going to put the 0 because that's a restriction. Okay? Okay, now here's what you're going to do. Do you see the equation that we had, the inequality, 4 over 3x plus 7 over x? Bring everything to the left-hand side, so minus 5 over 9 is less than 0. And now we're going to test values from each of these and see where we're going to get a positive and where we're going to get a negative. Okay? Now, which one of those numbers is a restriction? The 0. Let's put a little open circle there just so we know the 0 is a no-no point. Okay, so let's pick a value. Let's pick a value from here, like negative 10, right? If you plug that number in here, you're going to get a negative number, plus another negative number, minus a number. So is the result going to be positive or negative? Negative. Negative. So over there I say it's negative. Okay? Let me take another number, like 2. That's going to give me, 4 over something, 9, plus this, minus this. It is going to be positive when you try it out. Here, you're going to get a negative number, right? You would have to try them out, huh?
You have to show
I mean, you don't have to show me the calculations, but you have to do it in order for, you have to show me this sign chart. You have to show me this, okay? So now, what do we want? We want the case when it's less than 0. So all the negatives, that means it's this one and this one. So we say x is less than 0 or x is greater than 15. Now, because this is less than 0, none of these can have the equality dash or symbol, okay? Like it can never be greater than or equal to. Okay, so let's do another one.
Why didn't you change it to the equal side?
Because it's easier to solve it that way. You don't have to. But just when you get here, don't say x is less than 15. Just use x equals 15. You know what I mean? Because we just want the 15. Okay, let's do this. Yeah, the 15 is the point that makes it 0. Okay, so let's do this one. What's the LCD? 4x minus 3, x plus 4. Okay, 4x minus 3, x plus 4. Okay, so what we're going to get is 4. Yeah, we are. I kind of skipped that part. I'll go back to it. Minus 4. Oh, no, there's no 4 here. Huh? Oh, there was a 3, not a 4. Okay. So minus 4 x plus 4 equals 4x, x minus 3. Okay, so let's distribute. So this is going to be 3 x squared plus x minus 12 minus 4x minus 16 equals 4x squared minus 12x. Oh boy. Distributing the 3. So minus 36 minus 4x minus 16 is 4x squared minus 12x. Yeah. When we put all this together, so what I'm going to do is I'm going to bring everything to the right-hand side this time, right? So I'm going to have 0 equals x squared minus 11x plus 52. Wouldn't you know it? That doesn't factor. So what do we have to do? Quadratic formula. Let's do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, right? Like that, all over 2. Okay. Oh, that's supposed to be 121. 121. Okay, so we're going to get 121 minus 200 something. That's going to be an imaginary number, right? Okay, because x is imaginary, we say there is no solution. All that for no solution. Because the discriminant is negative. Okay? All right. So with that,